Howdy, y'all. So it is a snow day today, and I wanted to get a head start on our notes because we do have a test coming up in the near future, and I wanted to make sure that we're all on the same page about solving systems of equations with elimination. So we have already talked about solving with graphing. Remember, that's where you just look on a graph and see where the two lines intersect. And then we've also talked about solving systems with substitution, which is where you plug in something for a variable, solve it, and then go back and solve for your other variable. So we've already taken notes on that. All of those are on Canvas. But I did want to do a quick walkthrough for elimination, which is the next big thing. We're just going to do a couple of examples. I would really like for you to be writing this down. So if you wanted to get a piece of paper so that you could follow along, write the examples down, I think that would be super great because your brain learns really well when you actually write things, when your fingers move while you are learning. It's proven, scientific fact. So get a piece of paper and then we'll do a couple of examples so we can learn about elimination. Okay, here we go. Okay, so here is our first example. We have a system of equations, and remember, since we have a system, what that means is that this x right here is the exact same number as this x, and this y right here is the exact same number as this y. So they will mean the same thing at the end of this, and we will have as our solution an ordered pair, an x value and a y value that will work in both of these. So that's what we're looking for. Now, we've done graphing where we would graph these, and then the point where they intersect would be the solution, the x and y value where they're both true. We've done substitution where we would take, we move this over here so that we have x by itself, and then we could substitute for that x and figure out what the y was and all that good stuff. So now we're going to do elimination, which means we are literally going to eliminate one of these variables. So the thing is, we have two equations here. And unfortunately, fortunately, we need two equations to solve for two variables. I want to get it down to one equation with one variable so I can solve that, and then I can go back and solve for the other guy. So how do I get this down to just one equation with one variable? I need to eliminate one of the variables. Here is our penguin, Pedro the penguin. He's very excited about eliminating, and he is suggesting that we eliminate the y. I think that's a great idea, Pedro. Let's do it. So here is the y right here. Pedro, hang on, I gotta get rid of Pedro. He's taking up too much room. Okay, I'm better. So look at these. I have these two y's right here. Now, if I subtracted this equation from this equation, guess what would happen? What's 3y minus 3y? That's right, y'all. It's 0. So that eliminates the y. So that is exactly what I'm going to do. I'm going to subtract that whole equation. So everything in there gets subtracted. And you might be thinking to yourself, can I just do that? Can I just subtract one equation from the other equation? And I'm going to say, you bet your boots you can, subtract away. So let's do this. What is 2x minus 1x? Anybody? That is in fact 1x. I'm just going to write x. What is 3y? Take away 3y. Anybody? Correct. Nothing. So I'm actually not going to write anything there. I'm just going to write the equal sign over here. And then finally, what is 30? Take away 24. That is 6. Now, y'all, if you wanted to put a 0 right here to take the place of your y, you totally could. I don't put that because eventually I'm just going to narrow it down to that, which is x equals 6. But if you want to put a 0 there, totally fine. Now, this first example I made really easy because I wanted to just kind of show you the process. But we have already solved for, boom, we have x. We have solved for x. X is equal to 6. Now, as you know, our final answer must have an ordered pair to it. So what we have is the x value, which is 6, comma, so I need the y value to go right here. So how do you think I could figure out the y value? If you were telling me, I can't hear you because I'm recording and I'm in the past because you're watching this in the future. Anyway, if you were telling me, hey, Mrs. Ray, plug that back into one of those equations, plug the x equals 6 into one of those equations and figure out what the y is, holy cow, you are so correct. So you can pick either one of these two equations up here, take this little 6 and plop it in for the x. I'm going to choose this second equation just because the x is by itself, so I think it's going to be a little bit easier. So I'm going to, let's see, how do I want to do this? I'm going to just make a little arrow, I guess. Boop, 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 boop. And I'm going to rewrite this. So this is x plus 3y equals 24. I know that x equals 6, so I'm just going to take this 6 and I'm going to plug it in for the x right there. So 6 plus 3y equals 24, and you know how I like to put stuff in parentheses when I plug it in, just to kind of remind myself that that's what I plugged in. So y'all, what do we need to do to solve for the y? We want to get the y by itself, so I am going to subtract that 6 from both sides. So then I have 3y is equal to 24 minus 6 is 18. And then what's the last step? We're going to divide both sides by 3. And we get y is equal to 6. So now I can go back up here to my answer, my ordered pair, and just go ahead and write in that y is equal to 6. And y'all, that is the solution. That's the ordered pair where these two lines would cross, where x and y both work. Now, I have mentioned in previous units how to check equations, but we haven't really talked about how to check systems of equations. So I'm going to do that over here real quick. I think I'm going to switch to green. Let's get a nice green color for a check. So I'm going to check over here to make sure that 6 comma 6 actually works. And the way that you check is you plug in 6 and 6 for your x and your y into both of your equations. It has to work for both of the equations. So let's start with this top equation right up here. So I'm going to say 2 times 6 plus 3 times 6 equals 30. Y'all, what is 2 times 6? That is 12. 3 times 6 is 18 equals 30. And if I'm doing my math right, 12 plus 18 is, in fact, 30. So that guy checks out. Now, I have to check the other equation too, because it has to work in both equations in order for this to be a solution. So let me use the second equation, this one right here, and plug in my numbers. So I have 6 for x and then 6 for y, and that's 24. So that's just 6. 3 times 6 we already said was 18. And 6 plus 18, sure enough, hot dog. So that works for both of them, so that means that this is, in fact, correct. I've proven that it works. Okay, let's try one more example just with this type of elimination, and then we'll do a couple of other examples that involve a few more steps. Okay, y'all, so here's our next example. Here's my system of equations. The x is the same as the x, the y is the same as the y. We want to eliminate something. So let's eliminate the x. So why do you think that Pedro's over here getting really, really excited about eliminating the x? Why would we want to eliminate that one? If you are telling me, hey, it would be it would be easiest to subtract these from each other since they're the same. When I subtract this equation down here, the x's will cancel out. Pedro, I think that you've got the right idea. Thanks for the help, bud. I wish I had like a thumbs up sign. I'm thumbsing up right now. You can't see it, but go Pedro. Okay, so let's subtract this whole equation like so. So 3x, take away 3x, let's keep it simple, 3x minus 3x Nothing. Remember, if you want to write a 0 there, you can. I usually don't, but it doesn't matter. Now, this is where we have to be very, very careful. 4y minus a negative 7y. I'm going to say that one more time. 4y minus a negative 7y. So minus a negative means what? What's happening there? That is going to turn into a plus. So what we've really got is 4y plus 7y. So what is 4y plus 7y? That is 11y. Okay, samesies is going to happen right here. I've got a negative 1 minus 10, so it's a negative minus 10. So two negatives put together, that is going to get me a negative 11, right? I don't know why my 11s look different there. I've got this 11 here and that's fine. So if I get rid of the 0, I'm left with, I'm left with 11y equals negative 11. I want just the y, so how do I get the y by itself? Guys, it's just solving. We're just solving. So I'm going to divide both sides by 11. Negative 11 divided by positive 11, I think, last time I checked, is just negative 1. So in my solution, I don't know what the x is yet, but I know that my y value is negative 1. So how can we find out what the x value is? We are going to plug in what we know. We know that y is equal to negative 1 to one of these two equations. It does not matter which one you use. It will come out the same both times because the y, remember, means the same in each of them. The x is the same in each of them. So I don't know. I'm going to use the top one this time. If you want to try and use the second one and see if you get something different, by all means, do it to it. I would love to see if we get the same thing. So I'm going to rewrite this down here. I have 3x plus 4y equals negative 1. And I'm going to plug in negative 1 for the y. There it is right there. Thank you. Okay, so let's solve this puppy. 4 times negative 1 is, I believe, negative 4. So I'm just going to change that to minus 4 equals negative 1. I'm trying to get the x by itself, so I'm going to add 4 on both sides. Add 4, add 4. So I've got 3x equals 3, negative. And then to get the x by itself, I'm going to divide both sides by 3. And voila, x is equal to 1. So I can put that up here in my solution. And obviously, because we are accurate mathematicians, we should check our answer. So let me take both of these equations and plug them in with my answer and see if they work. So I'm going to start with the first one. So 3 times 1 plus 4 times negative 1 equals negative 1. 3 times 1 is 3. 4 times negative 1 is negative 4. And that is, in fact, equal to negative 1. So that one works. And then let's try the other one. I'm running a little bit out of room here. Let me, I can do this. Watch this. I'm gonna I'm gonna cheat a little bit. So I'm gonna write it really small. 3 times 1. It's a minus because I changed it to a plus. So it's minus 7 times negative 1 equals 10. And then watch this. We're just gonna zoom into that. Woo! Technology! So 3 times 1 is 3. Negative 7 times negative 1 is a positive 7. And 3 plus 7 is, in fact, 10. Huzzah! Okay, so I have proved that both of those work, so I can feel really, really good about that answer, and I'm done. Okay, so now that's the general idea of elimination. Now, sometimes the equations aren't set up so nicely where you have like a 3x and a 3x, where you can say, oh, that'll just cancel out, and we have our penguin friend coming in to tell us which ones to cancel out. It's not always that simple, so let's do a couple of examples where we have to change some things around. Okay, y'all, so check this one out. When you look at this one, it's not really obvious whether we should try to eliminate the x's or the y's because they're not the same, right? So what can we do to fix this? When I see this, I see that 6 and 12 are related to each other because if I just multiply 6 times 2, it equals 12, right? I don't see anything that's kind of that easy with the y's, but I know that, if I multiply 6 times 2, I can get it to 12, and then I can really easily eliminate the x's, right? So that's what I'm going to do. I'm actually going to multiply this entire equation, everything in there, by 2, so I can make it an equation that's easy to eliminate. And you might be asking yourself, Self, can I just multiply equations like that? Will they still be equations? And the answer is yes. You just have to make sure you multiply everything in the equation. Then it won't change the balance. It won't change what's equal or not. So let's do that real quick. We're going to distribute this to everything in there. So what is 2 times 6x? That is 12x. And then 2 times 10y is 20y. And then 2 times 20 is 40. So now, check this out. Okay, I'm gonna write, let me figure out, I'm gonna take this first equation and just drop it back down underneath here. So 12x plus 6y equals negative 30. So now when I look at this, hot dog, I've got 12x is here, 12x is here, so I can subtract and eliminate the x. Booyah! All I had to do was to multiply this by 2. So now I'm just going to subtract this guy to eliminate those x's. By the way, does it matter which one you subtract? The answer is no, it doesn't matter. You can subtract this guy from the top one, or if you wanted to, you could subtract the top one from the bottom guy. It doesn't really matter. As long as you eliminate your x's, your final answer will work out. So now I'm just going to subtract everything on that bottom line. So let's do this real quick. 12x minus 12x, that's just 0. Then I have 20y minus 6y. So 20 minus 6 is going to leave me with a positive 14y. And then, careful, because I have a negative here, make sure you pay extra attention when you see a negative sign. I have 40 minus negative 30. So minus a negative. What does that mean? That means a positive. So technically what that actually is 40 plus 30, which is 70. So I have 14y equals to 70. What do I need to do to get the y by itself? Let's divide by 14, y'all. So 70 divided by 14, let me get my color, 70 divided by 14 is 5. So y equals 5. So now we're back to the easy part where all I need to do is take this bit and plug it in up here. So I'm going to go up here as usual and write in the piece of the answer. I know that y is equal to 5. Now, y'all, I have a whole bunch of equations going on. I have this first equation, I have this second equation, I have the second equation multiplied by 2. Which one of these 3 equations should I plug in the y equals 5 to? I can plug it in here, here, or here. Which one do you think would work? It doesn't matter. This is so great. It literally does not matter. So you can pick whichever one of those guys you think is the best. I'm actually going to choose the second one right here, 6x plus 10y equals 20, and plug it in there. So let's use blue, I guess. So I'm going to write that equation again down here. 6x plus 10y equals 20, and then I'm going to plug in y equals 5. I'm going to plug it into that y right there. So let's do that real quick. So 6x plus 10 times 5 equals 20. 10 times 5, last time I checked, was 50. So it's 6x plus 50 equals 20. And then let's start getting that x by itself. So I'm going to subtract 50 on both sides, like so. So I'm left with 6x equals 20, take away 50, I believe is negative 30. And then last but not least, I'm going to divide both sides by 6. And that leaves me with x equals negative 5. So I'm going to plug that in up here at the top. Boop, 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 boop. Huzzah! Awesome. So we are doing so great right now. I'm going to try to fit in a check down here. I'm going to cheat like I did before and write them and then zoom in. I know you can't do that on your paper. but I can do that on my fancy iPad. So let me write these in. Sorry, I'm just talking while I'm writing now. Okay, so our answer was -5, 5. So let's plug that in right here for this first one. Make sure it works. So 12 times 5 plus 6 times -5. Was it? I've forgotten. Oh, golly, guys. I'm sorry. I mixed those up. Let me find what I'm looking for. Here we go. I'm so sorry you have to hear this part. Erase that negative there, and then put a negative here. Now we're cooking with gas. Okay, so 12 times -5 is -60. 6 times +5 is +30. -60 plus a +30 is, in fact, -30, so I can call that one good. Let's scoot on over to the next one. I remember this time the x is -5, so that's -5 right there. And then the y is +5, so +5 right there, equals 20. 6 times -5 is -30. 10 times +5 is +50. And when I add those together, hot dog, I get 20. So that is correct. Y'all, that means our answer makes total sense, and we are in business. Okay, I have one more example for you that's just one more step, just a slightly more complex system of equations. So let's do that, and then I will be done. Okay, y'all, here is our last example, and this one is going to require some work, which is delightful. If you look at the x's, I can't quickly eliminate the x's just by subtracting them, and there's really nothing I can multiply by 6 to turn it into an 8. There's nothing I can multiply by an 8 to turn it into a 6 that's not a whole number. So I'm going to put that off the table. Let me look at the y's. Is there anything you can multiply by 2 to turn it into a 7? I don't think so. What about, is there anything you can multiply by a 7 to turn it into a 2? No. Okay, so here is where we are. We are going to have to multiply both equations by something in order to get them to eliminate one of the variables. So let's think about this. I'm going to go back to the x's. What is the least common multiple that both 6 and 8 can go into? So I'm looking for a number that both 6 and 8 go into evenly, the smallest number that is. So let's think about factors of 6, multiples of 6. So 6 times 2 is 12. Does 8 go into 12? No. 6 times 3 is 18. Does 8 go into 18? No. 6 times 4 is 24. Does 8 go into 24? Yes. So here's what I can do. I can multiply this equation by 4 to get that 6 to turn into 24, and then I can multiply this equation by 3 to get that 8 to turn into a 24. What I'm aiming for, remember, is to eliminate one of the variables. I've chosen the x's, so I'm going to multiply those to eliminate those. You could just as easily multiply something for the y's to eliminate the y's. I'm going to show you the x's, and we'll go from there. So I want these to be 24 x's, so I'm going to multiply that first one by 4, and remember I have to multiply by everything in there. So here we go. 4 times 6. I'm just going to put this right down here. 4 times 6 is 24, and that's an x. 4 times 2 is 8y, and then 4 times 4 is 16. Cool, 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 cool. Now let's turn to the second equation. I'm going to multiply that by 3 because I know that 3 times 8 is going to be 24x, which will let me eliminate that. So let's distribute that 3. So 3 times 8 is 24x. Hot dog, we did it. 3 times -7 is -21y. And then 3 times -14 is, oh, let's do some quick math, -42, I believe. Let me check my calculator. Hang on. Okay, I checked it. It verifies we're all good. Okay, so now, guys, what I'm going to do is I'm going to eliminate the x. Let me get rid of this little arrow real quick so I have some more room. So I'm going to subtract that bottom equation. Remember, it doesn't matter which one I subtract. So let's do this. 24 minus 24, nothing. It's gone, 0. This is exactly what I wanted. 8 minus a negative 21. Careful there. 8 minus negative 21. So what does that actually mean? Minus a negative, that actually means plus. So 8 plus 21 is 29y. And then the same thing is going to happen down yonder. 16 minus a negative 42. Minus a negative. That means that is also going to be plus. So 16 plus 42 is 58. So I've got 29y equals 58. How, pray tell, do I get rid of that 29? Let's divide. So I ended up with y equals 2. Sweet. Okay, so let's go up here and start our answer set. That's going to be a 2. Okay, now I want to find the x, and I've got, oh my gosh, 1, 2, 3, 4 different equations that I could use for this. It does not matter. Literally matters not at all which one of these you will use. You will get the same answer because this is all a system. So all the y's are the same, all of the x's are the same. So I'm going to use this top equation right here, the 6x plus 2y equals 4, because I think that's nice and, I don't know, easy, neat. So I'm going to do that right over here in the corner. So I'm going to write, oopsie, I did a highlighter. That's not what I want. So 6x plus 2y equals 4. And then I'm going to plug in the y equals 2 right here for the y. So here we go. 6x plus 2 times 2 equals 4. Y'all, what's 2 times 2? That is 4. And that is equal to 4. Let's move some stuff around. So I'm going to subtract 4 on both sides. Uh-oh. Look at what's about to happen. 6x equals a big fat 0, which means when we divide both sides by 6, we're going to get that x equals 0, because 0 divided by 6 is 0. So up here, I can just say 0. Let me box that in. And then, obviously, I'm going to check, because I like to be accurate, and I want to make sure I've got the right answer. So let me write these in up here. I'm going to say 6x plus 2y equals 4, and the other equation is 8x minus 7y equals negative 14. And I want to say one more time, you need to check both of them. Don't get lazy and just check one. You need both. Okay, so I have 0, comma 2 is my answer. 0, comma 2. So that's the x, that's the y. Let's plug it in. 6 times 0 plus 2. Oh, I forgot to write the y. That's a y right there. Oopsie. Plus 2 times 2 equals 4. 6 times 0 is 0. 2 times 2 is 4. 0 plus 4 is, in fact, 4. Huzzah! Let's go over to the next one. And again, my answer was 0, 2. So that's the x, that's the y. So 8 times 0 minus 7 times 2 equals negative 14. So that is, do you see, y'all? Do you see how I said 0 out loud and then I wrote a 2 right there? I'm not sure what happened with that. That's my bad. Let's fix that. So 8 times 0 is 0. Negative 7 times 2 is negative 14. Negative 14 is, in fact, equal to negative 14. Oh, my goodness gracious me. This is correct. Okay, that is elimination. I know that was long. Holler at me if you need any help. I think, going to post a worksheet with some problems. Actually, no, I'm not. I'm going to give you a worksheet with some problems next class, but I want you to kind of look at this, look at these, get the hang of it. On the next slide, I'll write down some problems if you'd like to practice, just for the heck of it. If you want to just see if you can do it. Email me if you have questions. And that's it. I will see you soon. Bye. All right, y'all, here are some practice problems. There are 2 in each type of elimination that we have done. I'm going to let this sit for 10 seconds, and I'm going to move to the key. So if you want to write these down, pause it, and then the key will be coming up.